transactions and private keys and some other cryptography pieces, right? Because in this blockchain demo here, we can see we have all these fantastic transactions, right? All these things went through. But how do we know that it was Darcy who was the one to send $25 to Bingley, right? How do we know that actually happened? And this is where all those pieces that we just learned about in our testnet, in our MetaMask account, are really going to start to come to life here a little bit here. So here we have an example of public and private keys. Okay, at the top we have this private key, right? That was randomly generated. A private key is as it kind of states, is a key that you really want to keep secret because you're going to be using this as kind of your secret password for all your transactions, right? I can really pick any private key, anything that I want, and with it, this algorithm, they're going to use an algorithm. For Ethereum and Bitcoin, they both use this elliptic curve digital signature algorithm. It's a variant of just a digital signature algorithm, and it's going to create this public key, right? I'm really not going to go at all into kind of this digital signature algorithm, but just know it does use some of the hash knowledge that we just learned, combined with some other pieces to kind of get this public key here. So I'm not going to go too deep into it, but we have this private key that we create, and we get this public key. Now, this public key, we want everybody to have access to, right? This is, whole world can see this. This private key, we really want it to be private. We don't want people to see this. We're going to use this private key as like a password to quote unquote digitally sign transactions. And then people can verify them with this public key. So let's see what this actually looks like. Let's pick a random key, a more secure key, right? Because the longer it is, the more secure it's going to be. And if we go to signatures now, right? Let's say we have this message that we want, right? We'd say "Hi world," right? We want this to be the message. What's going to happen is this private key that we've created, we can use to sign this data, right? Remember how in the blockchain demo, we were hashing stuff, right? We're using this SHA-256 hash to get this hash. Well, we're doing something similar, but instead of hashing, we're using this digital signature algorithm to create this message signature. Now, what's really powerful about how this algorithm works is that you can create this message signature with your private key, but somebody else can't derive your private key from the message signature. And that's what makes this really, really powerful. However, if we go to verify using this public key, right? And so this is that 0403. This is that same public key. Using this public key, anybody can verify. Oh, let's go ahead and sign it again. Anybody can verify that this signature is yours, right? So you have a private key just for you, so you can sign things, and a public key so that anybody can verify something, right? So anybody can verify this, and let's say somebody tries to fake a transaction from you. They say, "Hey, this is their transaction." All they have to do is verify that this signature against your public key, and very easily this whole thing turns red because it isn't verified, right? The algorithm says, "Hey, that's wrong." So we can go ahead and take that into transactions in this exact same way. So if I want to send money, if I want to send $400 from, my address to another address, using my private key, I can sign that transaction. And anybody else in the world can then verify this transaction, right? And this is why when people say, hide your keys, protect your keys, this is what we're talking about. In our accounts here, right? If we go to settings, and again, the only reason that I'm showing you guys my mnemonic and my private key is because this is a dumpster account. I'm going to throw this away at the end of this video, or I'm just not going to put any real money in it. But when we look at our MetaMask here, we have this mnemonic phrase which allows us to easily get these different private keys, right? So mnemonic phrase combined with whatever account number will get us a private key. So mnemonic phrase combined with 1, we're going to get this private key. And this is when we look at account details, export private key, password confirm. This is going to be the private key that we're going to use to sign our transactions, right? If anybody else gets access to this private key, they then can sign transactions for us, and they can send transactions for us. And that's why we want to keep these private. So it works the exact same way, right? So this is why it's so important to hide your private keys and hide your mnemonics. Now, your Ethereum address is actually a piece of your public key. Now, to get our address in Ethereum, all we have to do is take this public key that we've created with our private key, hash it using that same Ethereum hashing algorithm, and then take the last 20 bytes. And that's how we'll actually derive to our address here. Now, knowing the exact methodology of how to get the address doesn't really matter because it could change blockchain to blockchain and could even change in ETH2. But just know that that is essentially how kind of these addresses are derived, right? There's some derivative of the public key, right? Because the public key is public, and using the public key in kind of any public way is totally fine, but not the private key. So that is how we sign our transactions. Note though, this isn't how we send the transaction. So this is just going to sign it, create a transaction for us to send. We'll learn later on how to send these transactions. Whew, so that was a lot of information there too. Let's do a quick recap. Your public key is derived by using a digital signature algorithm on your private key, right? And you want to keep your private key private at all times because you're going to use your private key to sign transactions. Signing transactions with your private key, you are the only one who can actually do this because you can't get the private key from a message signature. However, using your public key, anybody can very easily verify that a signature that's signed by you is in fact signed by you. In our MetaMask, our private keys are located in this account details section. You just hit show private keys and type in your password, and you'll get your private key here. And the address of your account is derived from this private key, and it's derived from this public key. So if you think about it, your private key creates your public key, which then can create your address. And there's a little barrier here, or a big barrier here, because your private key you want to keep private, and your public key and your address can all be public information.
Now, remember how in our MetaMask, we were able to actually create new accounts. Mine says account 6 because I've created actually a few. But how was it actually creating those accounts? Well, now that we know all this, if we go back to our blockchain demo here, what our MetaMask is doing is essentially taking our mnemonic or that multi-word secret phrase and then just hashing it with some number. So secret phrase +0 gets this, and it'll set this as your private key. And for our account 1, that'll be the private key, or maybe it's +1. The exact algorithm that it's using doesn't matter. But if you want to create a new private key where you just hit this create account button, the way it actually picks this account is by taking this secret phrase and then just changing this number. So if I'm on my MetaMask, I do create account. This right now I'm on account 6 because like I said, I made a whole bunch. If I make account 6, right? It's as if we just did the secret phrase +6 and created this new hash or this new private key and created this new hash, and it uses this to make a private key. And this is why in your MetaMask, if you share that secret phrase, if you share that mnemonic device, they will have access to all the accounts that you ever created. However, if you share your private key, it will just give them access to that single account. Secret phrase has access to all the accounts created in your MetaMask or your wallet. Your private key is access to that single account, and the public key or address, anybody can have access to, and it's cool for anybody to have access to. So when I'm thinking about the security of my MetaMask or my wallet, this is kind of the order that I think of it in. The seed phrase or mnemonic or secret phrase is incredibly important. Protect this at all costs, because if somebody else gets access to this, they will have access to all of your accounts. The second most important is the private key, because if somebody gets access to that, they will get access to a single account. And then your public key or address, which whatever, it's public.